Thank you. Hello, everybody. My name is Filip Cerny. I'm the product marketing manager at Progress Software, focused on solution Flowmon, which I'll tell you a little bit about in the second part of the presentation. But thank you for attending the short presentation that's going to be focusing on detecting, investigating, and responding to cyber threats. So before we move forward, let me share you a little bit about the company I'm working for. I represent a company called Progress. Just by show of hands, who has never heard about Progress? Just two? The rest of you heard? Super, that's great. So for those of you who haven't heard about Progress, we focus on developing the applications that you need, help you to deploy them and manage them safely and securely. So you might not hear about Progress that often, but the companies that you hear about, like Apple, Microsoft, and all the others, they do rely on Progress solutions and Progress products. Just a couple of the statistics to support my claims. We have top 10 tech companies rely heavily on Progress applications. We have 3.5 million thriving developer community, which is a really nice amount, I would say. 70% of the Fortune 500 companies are using Progress products, and the largest companies in the world, the top 30, I would say, also use the applications. So we've been established on the market for a while, little over 40 years. Now we also I came into Progress 4 years ago when we were acquired. So we just extended the solution into the security space. So that's why I'm here to talk to you about today. Here is a little bit of the agenda, but let me just skip that and jump straight ahead to the threat landscape overview and what are the threats that we are currently facing. So there is many of them. We know we've got ransomware that's been sort of in the main news since COVID and even before. Now there is a huge rise in ransomware as a service. So companies really need to do their best to protect themselves and make sure their data are safely secure. From what I remember, I'm a numbers guy, so I'm going to be throwing a little bit of statistics at you. Ransomware was on the rise when the pandemic hit since 2020. I remember I saw the statistics that ransomware attacks happens every 10 seconds in 2020. Then in 2021, it moved to that every 4 seconds there was a ransomware attack. And then there was a slight decline in 2022. So I was really surprised or really curious to find out what the 2023 numbers were. Just out of curiosity, do you think it was more or less than in 2021? So there was a ransomware attack happening every 4 seconds. Who think it was less, by show of hands? Who think it was more? Yes, you're right. So the real number is that actually there is 15 ransomware attacks happening every second right now. So that's just staggering. And now you can throw AI into the mix. So everyone now has access into the AI tools. Everyone can just ask ChatGPT to write me a malware code or something like that. So that also adds to the awareness and to the, let's say, to the fear that brings on when it comes to security. I think that AI can help us a little bit. For example, in the shortage of cybersecurity talent, that's been a problem since I came to the industry, I would think. And AI can definitely be a tool that can help us to, let's say, be in better, do better analysis, implement the AI tools into solutions, so we can basically guide L1 engineers to deal with threats and help them better respond. So I think that we don't need to be afraid that much of the AI, but we sure definitely can help work with it. If we look at the challenges, evolutions, and how it changed, I'm sure many of you remember that back in a couple of years back, like in 2015, we had zero visibility. We had some problems where it was operational. There was no network connectivity. You need to manually sift through the data, figure out where was the problem to find out how to deal with that. Well, if we fast forward today, we have to deal with different issues. We are severely overloaded with events, and then brings a lot of challenges. So among those challenges are we have no single correlated view because our networks are decentralized now. We have from the statistics I remember, I think 80% of the organizations rely on 2 or more cloud providers. So you have native monitoring from your AWS cloud, from Microsoft Azure. Then you have your private cloud and on-prem infrastructure, and you need to manually correlate the data if you don't have any centralized visibility. You get thousands of alerts every day, which basically is not humanly possible to analyze, and it's really hard to identify the real attacks in all the noise that you receive. Plus, and that's always been the issue, that we have a shortage of skilled security personnel. So what it's result to? Well, there is a high rate of overlooking critical events because we are overloaded. The staggering number is then more than 55% IT responders to the survey here show that they see more than 10,000 alerts per day, which is just insane. And that results that you basically have to tune policies to adjust to the sheer volume of events that you're receiving. And that leads to stress, frustration, fatigue, and basically you're way more likely to overlook security incidents because of the complex prioritization. Well, it's really hard to prioritize when you have that sheer volume. So these are the challenges that we have to deal with. So let's look at how we can do it. So this is the concept that was introduced by Gartner a couple of years ago, and it's called SOC Visibility Triad. Just by show of hands, who has never heard about SOC Visibility Triad before? Everybody? Super, that's great. So the SOC Visibility Triad basically tell us that we have 3 key pillars, like endpoint detection and response solutions. We've got agents that we deploy on endpoints, which is great, but that doesn't cover the whole infrastructure. Many of the organizations have EDR tools in place, but cyber incidents still happens. Then we move to the CM tools. We can collect logs as well, but your CM tools is usually as good as as the data that you're feeding it with. So then we have the key 3rd pillar, which is network detection and response tools. I remember back in the day, it was first called network behavior analysis, then it was network traffic analysis, and then later Gartner introduced it as a network detection and response tool. And the idea is that basically each of these 3 pillars basically makes up for the other 2's shortcomings. So if you have these 3 tools deployed in your solution, you're basically doing the best to help to have safe and secure IT environment. So let's look a little bit closer to network detection and response solution. So the idea is that regarding detection, there are a few key principles that that I can note. You need to basically proactively and continuously monitor your network environment and have early detection capabilities to recognize indicators of compromise, potential anomalies, and basically have that early detection so you can respond before it gets to the later stage, impacting your files, encrypting them in case of ransomware attack so you cannot access them. Second stage is once we've got a detection, you're alerted that there is a possible potential anomaly. You need to do an investigations. You need to have some digital forensics. You need to have the data available to understand where is the data attack coming from, who is responsible, when it did happen, and you need to have some evidence. This is something that the incident response teams which are basically a specialized group of IT personnel who deal with this sort of issues. And you need to have a chain of custody in place. So when an incident happens, you have an incident response plan in place, so you know what needs to happen, who's responsible for response, what other tools will be instructed to launch the response. For example, when you have an NDR that detects a potential anomaly, you can instruct your firewall to put the infected host into a quarantine, or you can instruct endpoint to block the host, and so on. And that leads me to the solution that we have here at Progress, which is called Flowmon. And you can think of Flowmon as your AI-powered security analyst that we deliver to you as a software, because it provides you with a powerful detection, so you don't need to manually sift through the data and have that early indicators of compromise right at your fingertips. With AI smart prioritizations, you are immediately aware of what's the most important issues that you need to focus on. So when you wake up in the morning, you go to work, you know exactly where you need to start with. And we help you automate analytics, so you know exactly when there is an attack, who other servers did the infected host communicated with, and which you should also check out. So how do we achieve this? Well, we have a number of different approaches or mechanisms that we have developed in our security engine to provide that capability. So it's a combination of machine learning, adaptive baselining, heuristics, as well as our own proprietary technology, which we call behavior patterns, that allows you to create your own detection methods on metadata level. And we also combine all of that approach, which is basically the definition of a network detection and response tool, that basically you have a solution that doesn't rely on signatures. But we still see the benefits of signature-based detection, so we complement it into our solution. So you've got signature detection also combined with our tool, plus the threat intelligence from reputational feeds. So how does the solution work? Well, the core of the solution is the icon you see in the middle, which we call Flowmon Collector. It's an appliance. It can be hardware or virtual, and you just need to feed it with your data. And the good thing is that you already have the capability in your infrastructure to send the data. I'm sure many of your core switches and routers can have NetFlow IPFix export enabled, and they can feed the data straight to the collector. Same thing you can enable on other devices such as firewalls or IPS systems. And when none of these things is available, you can also deploy our own dedicated sensors, which is a device we call Flowmon Probe. There is an added value when you rely on our sensors, and that is that we enrich the network telemetry with application layer visibility. So you get even deeper visibility. You can more effectively troubleshoot. You can see into the application protocols like DNS, and have basically tackle even more use cases for network observability and security. And then it's just a matter of extending a couple of the features. So the network detection response capability is provided by our own software module, which we call Anomaly Detection System, which is in short Flowmon ADS. And that is basically what provides that automatic threat detection and response capabilities. Other modules is Flowmon Packet Investigator, which allows you to do an on-demand packet capture. So let's say that you've detected an event, an anomaly, that someone is trying to maybe exfiltrating data out of your network to a blacklisted IP. We've detected that anomaly, and you would want to have a further evidence. Well, you can trigger on-demand full packet capture with this module and have a PCAP file available. And we also provide you an automated analysis of that PCAP file as well. And lastly, we have an application performance module to monitor a web-based application. So the value that we provide for us from a cybersecurity standpoint is that we can help you minimize the breach impact by monitoring the network traffic proactively and alert you on the compromises at an early stage so that the breach dwell time can be reduced. We help you reduce the number of events by connecting the dots between seemingly unrelated events, and build a full picture of the security incident and focus on the high priority ones. We help you increase staff efficiency because the solution is really easy to use by enabling less experienced team members to do complex investigations. You gain more confidence in responding to incidents, and with noiseless insight and hard evidence on the root cause, severity, damage, and impacted systems, the remedial actions are much more accurate. And you can have all that equalized level of protection in your whole hybrid cloud environment. So Let's look at an example. From these reports listed below from Verizon and IBM, I found out that the average time to detect a breach is around 56 days, with the average breach cost being around $4.5 million. This is just a staggering number, but let's just go through this example. What if we were able to reduce the detection time, let's say down to 2 hours? So substantially less time for an attacker to move unnoticed in your network and gather data. Let's say that with that intelligence that we provide, so from detection through forensic analysis and investigations, you know who is responsible, which servers were impacted, so you can have even faster response time. And instead of let's say recovering 60 devices, you only need to recover 5. So we can just assume that just with these benefits, you're capable of cutting down the breach cost. I don't want to say to 0, but ideally yes, but let's say to $500,000, with the average cost of Flowmon for, let's say, a mid-enterprise company that can be around $80,000. The return of investments into Flowmon basically equals to a 1 security incident. If you look at a customer story, and I'm going to show you a similar example to this one in our demo, is that customer detected an infected device on their network, and what happened was that standard laptop was acting as a gateway to the internet, basically broadcasting everyone, if you want to go to the internet, go through me, and the malware-infected laptop was getting access to sensitive data like passwords and logins. And you might ask me, how come the endpoint detections and response solutions didn't catch this? Well, in this example, there's a simple explanation. The antivirus just wasn't updated, and the signature base didn't detect it, and that just like that, the endpoint detection failed. So having that continuous monitoring and continuously looking for those early indicators of compromise is something that helped to stop this from causing a further damage, and this incident was resolved by an IT within an hour. Let me then move to, there we go. So this is an example from our guided demo scenario. So just to give you an insight into what the solution looks like and what kind of information that you can get. You can see an timeline with different anomalies. You can filter by different detection methods or priorities. And we see that we have a number of critical anomalies detected. So let's explore the upload anomaly, for example. And just like this, with this quick drill down, I can see the IP address that is responsible. I can see the timeline. I can see a short detail that there is an upload of 22 megabytes of data to an blacklisted IP address, which is the icon of the skull that tells me it's blacklisted. And this is a Taiwan flag. So if I would want to investigate a little bit further, we can have this standardized event detail for every anomaly, so we know exactly what type of anomaly it is with the short descriptions, how it corresponds to MITRE ATT&CK framework, so you know exactly at which stage of the attack you are. So that helps you also prioritize which events you want to focus on further. And you've got timestamps, you've got the source IP address. We also connect the user identity. So you, in this case, you know that this was Adam's Ondra notebook or device that has been infected. And we can even provide further evidence in this tab, like communications of flow, which is basically the hard evidence that IT operation needs to prove that the device is responsible. And I mentioned before that we also complement the signature-based detection as well. So in this case, it was also triggered, and we can see that this was a possible blue key vulnerability through RDP exploitation. I can then just as easily filter out the IP address and see what other malicious activity happened. And just like that, I can get a list of all the steps that happened before the final stage of upload. So First, the IP address was scanning the network. Usually, how the first step always starts, trying to figure out the environment and what possible systems we could infect. Then there were two attempts at dictionary attack, or basically breaking the passwords to the Windows and Samba server, which is the IP address ending 12 and 113, which was these two steps. Once an attacker got a hold of, basically managed to break through to the Windows server, he installed a keylogger application, basically collected the password and logins, and then was able to connect to the Samba server where the sensitive file were stored. Once that happened, the only thing that the attacker needed to do was establish connection with the command and control server, which is the IP address from Taiwan that we mentioned earlier. And then in this case, what happened was quite sophisticated. The attacker actually split the data into smaller chunks and using ICMP protocol just ping it out of the network. So this is something that we're capable of catching because ICMP protocol is not supposed to carry a payload. So we can flag it as a potential anomaly, as well as in the exfiltration stage, multiple anomalies were triggered. In this case, the ICMP and the upload anomaly that we started this whole process with. And once the attacker successfully exfiltrated the data out of the network, the only thing that was left to do was to encrypt the data on the Samba server and leave a ransom note. So usually, if you look at the timestamps, we can see that we've demonstrated this attack within 30 minutes. But usually, in reality, this takes days, weeks, or even months from the early stage to the final impact. So attackers trying to move throughout your environment laterally and be unnoticed. So with that solution, such as Flowmon, you can get that early detection and have enough time to respond, to instruct your firewalls and put the IP address into the quarantine before it gets to that final stage of encryption of your data. So with that, we're basically reaching the end of my presentation, and I invite you to come talk to us with our partner Hainan at our booth. And if you want, you can easily arrange a short call with us, with our pre-sales engineer. We can show you a little bit more in-depth demonstration of our product, other capabilities that we're capable of doing. And if you want to try the solution for yourself, we do a free of charge proof of concept, and we would be really happy to show you what's lurking in your environment. Thank you very much.